In this video, we are going to talk about nesting and what you can do in the nesting module. Nesting is basically fitting elements into larger panel for production. Once this information is set, you will be able to export these into lists or export shop drawings with specific dimensions, all the way to machine export. So let's get started. Before starting with the nesting, the first thing that you need to make sure of is that all your elements you wish to nest have already production numbers. So here it is not the case. So let's start with this and list, production list, run the calculation. And now here we all have our production numbers. If you do not have element with production numbers when entering the nesting manager, you will actually be warned about this. So make sure to keep this in mind. Now we are going to go to Tools and Nesting Manager. So here just a quick overview of how this nesting manager is working and what's the logic behind it. So here you have two tabs, panel and panel nesting. When you will get starting, the panel nesting will be empty simply because this means there is no nesting available or there is no group that have been made previously. When you go here to panels, you will be able to select the elements according to material and thickness. This is the way they are sorted in this table. As you can see here, as soon as you select a line, it will highlight the element in your 3D. Simply it means that they are part of this current selection. You will then here be able to create the new panel nesting according to your selection. This is something that we are going to look into next. If you would like to create manual group nesting, so you will say, for example, I would like these three to be optimized only between them, not with the others. When you select them, it's going to actually affect this window. If you're looking for more ways of creating automatic nesting group according to specific attributes, please check the already available video called Nesting Sorting. It's available already on the YouTube channel. So we won't go into that direction here. What we are going to look into here is really how to use the nesting manager and using the nesting module. So here we are just going to rely on simply material and thickness. When you go to create new panel nesting, it's going to open this window. And in this window, we have the basic information about the future nesting group. By default, it's named after the name of the material and its thickness. The two values here that are grayed out, they are simply here as visual cues, but are not something that you can edit. It comes from the element selected. But here you could make that name the one you'd like. Then below this, we have three options. In this video, we are mostly going to work with no optimization or width length optimization. The external nesting, this is something that we are going to look in a future video. What you have here on the right hand side depends on what you've set here. Let me explain. First, if you do not see this side by default, you simply need here to open it with this arrow. Here on the right hand side, you have all the default settings. This is basically the setting that you would also have available in the nesting module. So at the moment, we are not going to look into them as of yet, or most of them, simply because it would make more sense to see them directly in action in the nesting module. Then we have here width length optimization. This is something that we are going to look briefly at the end. It's not something that I want to do right away. This is simply a way to automatically generate the nesting volume according to a set length and width. What's here important to mention is the cut width. Since this length optimization will automatically place the element along their length, so this is simply a one dimension optimization. We will place the element in the nesting panel along their length, so you cannot have two elements in the panel width. This will require to use external nesting. Again, this will be explained and looked into in another video. And here, when the elements are placed one next to another, or one after another in this case, you will have a gap in between each panel, accounting for the cut width. One thing here that is really important to mention is that if you run the optimization automatically like this, you will still make sure that this value actually matches this one here. This shift in nesting are two values that will allow you to move element in set increment, simply using shift arrow and control arrow key. This allows you, when you create manual nesting, to simply account for the cut width without having to do the same offset over and over again. So this makes this adjustment easier. And then here again about the other elements, this is mostly about how the nesting module will behave. So nesting volume layout, this is simply how they are seen in the nesting module. So this doesn't really change the result, simply the display. Same goes for how should the unnested element be sorted. By default, it's by production number. This is what we are going to check. Then shift and nesting, this is something that we've seen. And then here, manual generation and nesting volume. So how this element will be generated. So you can here enter default values and automatically generated by length. You will be also able to run the length optimization directly within the nesting module, so you don't need to set it here right away if only some of your elements should be run with this function. So here you could actually, this is something that we are going to do right away, set the actual value for this to be the same as this one. So like this, if we need to run it directly in the module, which we are going to do instead of doing this one, we will be able to use these values. Here at the bottom, this is simply the shop drawing export setting that you will be able to load. This is something that we are going to check briefly once in the nesting module. And the last area, this is the volume generation rule. This is something that has been also discussed in an existing video called rule-based nesting volume. So let's go ahead and create this nesting group. Now that the nesting group has been made, you see that when we are in panels, the color of the element has changed. Basically, it simply means that if they are yellow here, it means that they belong to a group. If they will not be added to a group, they will be white, as we've seen earlier. Then if we check the nesting manager itself, we here have a info color. So not grouped, it was the case earlier. Then partially grouped, only element from that selection belong to a nesting group. Fully grouped, this is the case here, and then once we would have all these elements placed in nesting volume, we will have a star next to it, so we know this is fully completed. If you go back here to the panel nesting, we currently here have the information about the nesting group we've just made. So here currently we see that none of the parts have been nested, and here again you have some of the information that will change according to the status of the optimization. And here on the right hand side, you will have access to basic information about the current optimization. So here we have 8 elements that are here. They are all unnested, and we are 8 active elements that you can also remove from this nesting group if needed. Okay. If you were to do so, when you come back here, you will see that we have here these elements are the inactive one are nested, the active one are not nested. One thing here that you might want to know is, since these two group have the same actually group and thickness, if you select these ones that don't yet belong to any nesting group, you will see here that you can either create a new one or simply add to the previous one, or simply the compatible ones. So you may have one or several groups here available. And then we can come here and we are in the same at the same stage we were earlier. Then if we scroll down here, this is simply a way for you to edit the setting you've made when you made that first nesting group. So you can actually edit those. You don't have to set them right away if you don't want to, or if you want to edit specific values at the end, you will be able to do it here. But we will see that you can also change this value directly in the nesting module, and this is where we are going to go now. For entering the nesting module, you have two ways. You can either double click on the group you wish to enter or simply select it and press here, open. And we are now in the nesting module. So here we are the element sorted by production number. So 1, 2, 3, 4, 5, 6. If you want to, you have here also access to the attribute display. So here we see that we have all the different production numbers of the element shown. Here we have 3 identical one. That's good. Okay, so let's start with the automatic nesting. Let's say that we would like to select element of the same width. So if we go here, for example, and here, and see if they can actually fit a single panel. So if we now go to add nesting volume, you will have here different option available. This is what we are going to go through in this video. Length optimization. When you click on the button itself, you run the function. Clicking on the gears allows you to do some setting. So here, position in nesting volume, we would like the element to always be placed on the bottom left of the volume. And do we want an offset from the side? Here we don't want to. So here the horizontal offset is defined in relation to the starting position of the first part of the nesting volume. So here, basically, if this element is at the bottom of the nesting volume, do you wish to add like an inch or a quarter inch from that side? Knowing that our element here are 10 feet and we've set that these volumes should be 11 feet wide, actually let's do this and add here like an inch in both direction. And here we will simply run that length optimization on these 3 active ones. You can give this one a name. I will just give the name of the optimization we run on this one. And here you can set the width. And as you can see here, this width is the value we've set in the default setting when making this nesting group. And then here we have the length, 46. You can of course change this value or simply confirm the value with a right click as you are used to in Cadwork 3D. And finally, the cut width. And here, automatically, you are going to have the element placed in that optimization. We can see here that we have a 1 inch offset on X and Y according to the offset we've asked, and the element to be placed near the bottom left edge of the nesting volume. And if we were to zoom here, we do have here, of course, that 516 cut width. What we are going to do here, we are going to add several elements with different ways, and at the end we are going to check the option we have to actually adjust the size of the volume, either manually or according to their content. So let's here continue. These ones, it might be something that I would like to optimize by hand. And so here, if you go to add nesting volume, so here we have one that we are not going to use. It's the external nesting. It's the one I mentioned earlier. It will be using an additional program called OptiPanel. If we go here, rectangular, you will then simply have to set the name. So you can either set here a new name or no name. And always pay attention here, you have shortcuts available. So if you want to set a new name, simply Control N. And here that will be rectangular. Again, I'm using the type of nesting I'm using. And here it's going, since we didn't have set any of the default setting, you will here need to enter them. So let's go with, like, this one will be 10 feet and let's say by 60 feet. And then here you see, as you go, it's going to ask you again to add elements, always using the same values. It simply allows you to create more than one element at once. You can also, once one has been done, 6 to copy. I want 5 of them, and you have 5 elements. One thing here about these dealing with nesting volume and parts, if you start by activating a part, the only element you can select will be parts. If you wish to select nesting volume, you will first need to left click on one of the nesting volume, and now you can actually select nesting volume. The reason for this is, as you can see, you cannot select both nesting volume and element at once, simply because they don't have access to the same function, and usually you don't deal with them at the same time. So here let's just get rid of those ones. And as you can see here now that we have several nesting volume, you always start with 2 million. So this is the starting number for all nesting volume. So 1, 2, and 3. If you have more nesting group, it will always use the next 1000. Okay. So now that we have this, we are going to try to do some manual nesting. How? So this one is 9 feet wide. So here you can select your element and 5 to move, and here you can place them directly according to the point. If you want a more visual transformation, simply use the glide command with G, and here you can actually rotate and place the element as you'd like. So here, now I could do a 1 inch on either side. So here I can do 5 X, Y, and 5 Y, 1 pretty easily. But we've seen earlier that we had actually setting like shift distance 1 and 2. Currently, that second distance here is set at 6 inch. If we would like always to have this kind of gap around and we are working with manual nesting, could be a good idea to actually set this to be this offset. Like this, when we are going to run the manual optimization, you will be able to use this value. So here, for example, I'm just going to use the 516. But here on this case might be a bit tricky because of this angle cut. And let's say that we want the 516 to be actually parallel to this. So here there is no easy way. The only way you would have is actually to add an actual line and make sure to move this one here. Because if you were to use the shift, you see that it's a 516 horizontally or vertically, but you cannot actually project it according to a certain distance. So always be careful about this. And here we are going to take the last one here, and let's see if it fits. No, it doesn't. So we are just going to here maybe adjust the width just to have something where we could fit these 3 elements. Or actually, you know what? Let's just use this one. And here we would like to add that cut width, so we can use Shift and arrow key. We're just going to leave that at the moment. Would be interesting to see how it behaves afterwards. Okay, and now I could select this one, add nesting volume, and here you have rectangular plus over measure. Here again you have some different setting, and you can actually set over measure from the rough size of your element. So here I'll go like 1 inch in all direction. Can set the name, so that would be over measure, and right away it plays this element with a nesting volume that is simply 1 inch greater in all direction. And for the last one, we have here rectangular from geometry. So if we check the setting, we have like the offset horizontal and vertical we've used earlier. The position on the nesting volume, it's the same setting as earlier, and simply left click, and that will be Control N from geometry. So here we now have the element with that offset. But this is not an option that is widely used, to be honest. So now that we have all these elements, what can we do about the current result? Of course, here we have some elements sticking out, too much leftovers. So how can we actually adjust, stretch, or basically change these nesting volume? One thing here is if you try to get out now, knowing that you have some element sticking out, or even some element that could be considered as colliding. So here I'm just going to force this. If I use Shift and left arrow key, these two elements are now actually touching each other, meaning that it's actually impossible to create that cut. This is what we will consider to be actually a collision. And for that matter, actually what we consider a collision is any gap between two elements narrower from the first shift distance, so to that 516. So even if this element would be, for example, right here in the middle, it's smaller than 516, so we'll have collision. Oh, here we go. So here, that is what would have happened. Also here, if I did not place that correctly, but simply did this is smaller than 516, that will be considered as colliding. So if we exit here, active parts are not completely within the volume. So here, this one is sticking out. But we knew about this, so we'll just say yes. This is colliding. So when you try to exit, it's going to run all kind of verification. If you are to get out for any reason, the next time you are going to enter the nesting manager, you will here have specific warnings. So here, attention, we have colliding elements and outstanding parts. So parts that actually stick out from the volume they are assigned to. Let's get back in. So first here, fixing the colliding we've seen pretty easy. Shift arrow key, now it's all good. But how can we do for this one? If you're familiar with working in 3D, you could say, yeah, I just need to stretch this at least to this point. So select it and use stretch. And as you can see here, there is a lot of options available when selecting the nesting volume. And as you can see, those are not the same as when selecting the element itself. This is why you cannot actually select both of them at once. They don't have access to the same functions. So here, stretch, and then here you see that you have specific options. So you can be, by default, it's always along the length. So now if I select this point, it's stretching along this. If I do 7, you can also set along width with B and say, go to this. So you can, like this, actually adjust manually the shape of the volume to its content. 7 and here, and then if we would like to add an increment, because we want to make sure that this will be a correct cut, and let's say that we would like to give like a inch or 2 inches, so 7 A, and here the new length is, let's go with something round like this. So you can do all these kind of things manually. But what you can also do is when you select the element and when you go to stretch, there is also the adjust nesting volume. This is what the option was here, like adjust nesting volume. So if you were to adjust, you will have here different questions. Adjust the nesting volume length according to nested elements. Enter over lengths to nesting part. Basically, it's okay, how the part should be placed in the nesting volume. So here we want to keep what we had said earlier. So we are just going here to enter the value. It was 1. And here we are actually adjusting along the length. Nesting volume overall length. So here, do you want the length to be something fixed, or do you want actually to run a calculation, or basically consider the elements that are already nested to set the perfect length? So here let's go with 0. But the thing with this is that this length might not always be round. So here we have also the nesting over length. It's basically the same thing as what we've set here at the beginning, so 1 inch. And here you have the rounding value. Let's say that I don't want to produce any nesting panels that are not in 1 feet increment. So simply 1 feet and enter. So here it will automatically adjust the length. And so here it's going to make sure that this element is perfectly round. This is something that, of course, you can do also on the other direction. So 7, C to adjust, and here it won't be about the length, but width. And here we want 1 inch at the bottom, over measure at the top 1, rounding value 1 feet. Yeah, didn't change anything. That was the closer as we can get with a full full feet panel width. If you need to adjust some others, when you go to 7 and C, you see that you can also use the previous value. So if you do V, and it's going simply to give you exactly the same value over and over again, so you can actually adjust them all. You can also cut the nesting surface with simply C, and here selecting, for example, X, and here we go. Knowing this, you can also, since you can cut, you have also access to functions that are classic to the 3D, and for example, the cut with offset. Let's say that we want to adjust this and 1 inch from here, but we don't want to use the adjust. You can also do this with the cut. Simply use C to cut, and here offset, and that will be 1 inch, horizontal cut from here. So it's cut 1 inch from this line. So you can use all of this to actually adjust all of your volumes. One thing I would like to show you here is that you can also move element from nesting to nesting, or nesting group from nesting group. So here, what we are going to do is, if you try to select one, you see here that there is modify nesting group. And currently here there is no group actually available. So if we were here to exit this and go in the nesting manager, and what we are going to do is simply create a copy of this guy. Should the existing nesting volume be copied? No. I just want to copy the group itself with all of its settings. So of course this one is empty. As you can see here, when you have several nesting groups, you will find them as scenes at the bottom. So when you hover your mouse on top of this icon, you have actually information about the nesting inside. So here, for example, we have 8 nested elements, we have 5 nesting volumes, and we are using almost 81% of the material. If you click here, you can actually jump back and forth from one to another. So here, if let's say that we would like to, for any reason, have this to a different nesting group. Here you can select the volume or the element inside. If you are selecting the volume, modify nesting group, you will have access to all nesting that are compatible. So here in this case we are only considering material and thickness. But again, if you are using, as described in the previous video, group sorting, If you take into account specific sorting attributes, they will also be here taken into account. So you can here send the nesting volume to that other group. And as you can see, the element also followed. So you can come here and now you have this element here only. If you were to select the element or one element, modify nesting group, can send them back. You will always keep the nesting volume. And when you come here, the elements have lost their, their nesting. So always be careful about this. If you want to keep the nesting information, move the nesting volume that got element inside. If you move the element, they will leave without their nesting information. So here briefly, I'm just going to do the nesting here again quickly, and to simplify things, I'm just going to do something like that. Okay, so now that we have the nesting volume and everything ready, if you want to, of course, this can be sent to a machine, or you can even export shop drawings. So if we were here to check the settings, so pretty standard for an export, you have here like which layout you are going to use, which output format, so basic export stuff. Here how the frame should be organized once sent in 2D. Again, this is simply drawing or organization, not really about the result itself. When you come here to display, you can set the scale, fixed scale, automatic, or used from defined list, which is the list you have here, where you can here select to remove a specific scale, or you can create new ones. Dimension here, you can have dimensions on the element, and here simply overall dimension of the nesting, or simply the element, or both of them. If you dimension the element inside, if you have a lot of elements placed in one nesting, this might actually call a lot of dimension line if you are using this first option. So in that case, you might want to use this one. It's going to dimension always basically the counting line on your drawings. If you want to have also the coordinate of the element placed, as well as center of gravity and direction. And then the description, the same as in all export. This is simply about the labels or the description or attributes that will be written on the element in your shop drawing. So this is something that you can set for the nesting volume itself and for the nesting element inside. So let's keep here the default setting and simply run the export. It's going to ask us to select the element we wish to export and right click to confirm, clipboard number 1. So here I'm just going to exit this simply because I need to create a 2D file. So file, new 2D file, and now we can paste our result. So here I'm just deactivating, and now we have here all the dimension we need. So the offset, the dimension of each panel, saw curve, information here about the nesting volume. This all came from which layout has been used and how it was actually set. And we have basically all this for all the elements we've exported. This data can also be found in the 3D when you select an element and press 1. In the modify menu, you will see the nesting group it's assigned to and the nesting volume it's belong to. If I were to select an element I know is nested with other elements, if you use the Ctrl A, you can also select the element that are optimized in the same volume with nested part I. So these two belong indeed to the same volume. You can also select the element that belongs to the same nesting group with Alt I, nesting group. This nesting information can also be sent to a list. When you go to export, list, it has to be a production list because that optimization was run on production numbers volumes. List output. And here we have the detail of all the different volumes we need and what they actually contain. So we have here the dimensions of each of these panels, and we know basically what they will be used for. And of course, if you also want to export this to a machine, export machine, and we will here export as an example a BTL, let's do 10.6. I will simply here run basic calculation on this element. This is not really what we are interested in right now, so I will just run quick calculation. So here we're just going to check this element to make sure that no error. Okay, so everything now is flagged green. We can now run the export. And here when you run the export, it will ask you if you need to also include and export these nesting information. So here we can just say yes. And when you open your BTL or your other machine file, for that matter, you will get that nesting information in. And so here we can see in the viewer, we have the actual project, how it's placed. But if we check here in the hierarchy, it's actually the production number of the optimization and its name. And inside we have information about the element contained and the different processes. And one thing to finish, as you can see, if we were to get back to the nesting manager, all the small modification we've done in the nesting module about the default settings, like when we set the different sizes and such, will then be available in here. So you can actually review what you've set, what you've changed in the different in your different nesting group, and you can also edit them. And the next time you get in the nesting module, you will have these updated values. One thing about this setting is you can of course save them here, save. So you can save here your settings. I'm just going to call that default nesting. And here, when you go to others, default nesting setting, adjust, you can here actually load these new settings. So like this, each time you are going to create a new nesting group, it will always start with your basic settings. I hope this helps. And again, if you are looking into more advanced nesting, make sure to keep an eye on our YouTube channel. A future video will come in, I hope in the next weeks or hopefully the next months. Thank you.